This is what I get rounded. What am I supposed to do to my exponents? Add them. So it's going to be 10 to the 10th. Now, does someone see something wrong with that?
Yeah, it takes too long.
Okay, this needs to be a number between 1 and 10. So let's put a little note here that says I have to fix this. Fix it to make it a number between 1 and 10. All right. So to fix it, we're going to have to move the decimal, correct?
Yeah.
If we move the decimal, we have to do something with our exponent as well. So let's make us a little star note here that says, these are probably your two most important notes. If you move the decimal left, and I'm going to draw the arrow, if you move the decimal left to fix it, the exponent gets larger. So let's look back at our problem. Am I having to move my decimal to the left or to the right? I have to fix it, and to fix that I needed a number between 1 and 10, so I'm moving the decimal to the left. I'm moving it to the left, so it should be 5.823. If I move it to the left to fix it, what does it say about my exponent? It gets larger. However many spots it gets moved, that's how many spots it gets larger. Perfect. Times 10 to the 11th power. I moved it one spot, it needs to get one spot larger on my exponent. So that's pretty much as difficult as it gets, you know? Yes?
Like, why exactly would it be 11? I thought you had to count the spaces.
I had to count one space over, okay? And because I had to make this a number between 1 and 10. And so, since I had to move it 1 to the left, I have to add 1 to my exponent because I'm moving it left. My exponent gets larger, 1 larger, okay? Let's put another note. If you move the decimal to the right, what do you think is going to happen to your exponent?
It gets smaller.
Perfect. Let's jot that down. If you move the decimal to the right to fix it, the exponent gets smaller. So we will try another example. These notes here you're probably going to have to look back at. Remember that left gets larger, LL. Left larger, okay? If the decimal gets moved left, exponent gets larger, LL. Okay, I'm going to turn my page and do one more example there for you. I'm going to throw some negatives in there because negative numbers always make our head hurt. So let's make our head hurt. Here we go. 2.34 times 10 to the 5th divided by 8.78 times 10 to the 8th. Okay, first thing, it's a division problem. I know it's division because of that fraction bar. Let's go ahead and divide our constants. Type that in your calculator. Round it if necessary. Okay, I have 0.267 rounded. What do I do with my exponents?
You have to fix that, don't you?
We'll fix it at the end. Subtract. What is 5 minus 8? Okay, here's what we have so far. Does everybody see how I got that? I divided here, I subtracted my exponents. Now I have to fix this. I need to make it a number between 1 and 10, so I'm going to move
To
it.
the right.
How many spaces? 1 space to the right. If I move it to the right, my exponent gets
Smaller.
smaller. Okay, be careful. Smaller when you're negative gets further and further away from 0. So if I'm getting smaller with a -3, what's it going to be? Yes.
Marcus Levitt, come to the office, please. Marcus Levitt, come to the office, please.
So there's my final answer. A lot of people make mistakes on that because let me draw my number line real quick for you. Jot this down with me. This is -1, -2, -3, -4. The further you go this way, the smaller you get. Okay? So if you're at a -3 and you need to get smaller, then you have to go left, because that's getting further away from 0 and the value decreases the further away from 0 you get. Okay? Let's try one more on that with multiplying. Do this one. 4.1 times 10 to the -2nd times 9.5 times 10 to the -3rd. Okay, try that.
Do you say out loud or?
Do it on your paper. I'll be working at the same time you are. So you do this. It's going to be that times that. Be careful with your exponent. This is a multiplying, so I've got to add. But it's not finished. I'm going to have to fix this to make the number between 1 and 10. So I'm going to move this to the left. If I move it to the left, my exponent gets LL, larger, left larger, okay? So if I move it to the left, my exponent gets larger. When you get larger, you get closer to 0. So what's that going to be? Thank you, -4. There's your final answer. What do you think?
It's pretty simple.
You just got to be careful with your negatives, okay? It's not bad.